Okay, so the planet is dying. Nobody will speak to me about the possibility of getting energy that will save the planet, but that's the way it works in academia. They they pick out this nonsense about multi-universes so that they can keep funding their particle accelerators and all this stuff. Well, we're looking for multi-universes. That's absolutely ridiculous. When I'm looking for saving the universe we're in right now, how about we do that? That would be kind of interesting to me. Okay, nobody's going to bother following this, trust me. If you're not really deep into this stuff, nobody's going to understand it because you can't understand it. It makes no sense the way they presented it. And the Higgs boson could prove the multiverse theory of correct. That's insanity. Literally, what we're getting now from science is they're so lost and they're trying to come up with a concoct all these crazy scenarios. It's insane. But back in 2012, they did find a particle that had an enormous amount of energy, which was, they call it the Higgs. And what is it? One of the most important components is a standard model because it is a quantum of a scalar field. Well, that's, again, you're not going to understand any of this. Initially, scientists did not know what mass the Higgs boson has. In the standard model, it is a free parameter that is introduced into the theory by hand. They're just guessing. It's just insanity guesses. But years later, the mass of the Higgs boson is now known to be approximately 125 giga electron volts. That's 125 billion electron volts. They're saying these Higgs bosons. They're very energetic. I can tell you that. Although I think it's not exactly the Higgs boson. Well, we'll talk about that. The Higgs boson, like many other elementary particles, is unstable. They have to be broken apart. The white has to be broken from the black. Yes, they're absolutely unstable, and they only last for like done. This time is so short that the Higgs boson produced at the collider has time to travel too short a distance to be directly measured in the detector. Well, listen, what they are doing is they're slamming them together and they're flying everywhere and they're seeing, you got that energy for that time, done. So they can't do anything more. We're seeing them squirt out. Well, yes, they have to come back together very quickly. That's when we see the blacks come back to the whites, no question about it. But we see it in a controlled manner, not like they're seeing it. They're just seeing a big blob and gush go flying. So in other words, they can't, currently 9 orders of magnitude off from the standard model. They just don't know. They have no idea. The lifetime of particle, however, can be found not only by observing its motion, but also from the shape of the amplitude of its decay into other particles. Absolutely. I showed this. Exquisite detail. Anyway, it goes on and on and on. They just don't understand what they're doing. It says each of the existing theories has its positive and negative side. The new theory proposed by us may have somewhat more rights to exist because it alone explains 2 unrelated fundamental mysteries of physics at once. In addition, our new theory predicts some features that could make life easier for scientists looking for the dark matter particles. I've shown them over and over and over. I don't know. All right, this is the state of affairs in physics now. Listen to this. They're trying to come up, and I'm going to tell you right now, it's because of the 2 particles that I've been showing over and over for years now, and there's no way for them to account for them, so they're coming up with all these crazy stories. According to the new theory, in the earliest period of existence, the universe was a collection of many parallel universes, in each of which the Higgs boson had its own unique mass value. Universes in which the boson had a high mass value were the first to collapse. Who came up with this? In the crucible of the Big Bang. Big Bang of what? Where'd that come from? The more mass the Higgs boson had in any particular universe, oh man, the earlier it collapsed. Well, obviously. And our modern universe may be one of the universes with the lightest Higgs bosons that manage to survive the cataclysm and not collapse in the process. Well, and just about anybody can figure that out. Now, in addition to this frankly ridiculous, fantastical scenario, the new theory includes two new particles to go in addition to the known particles defined by the standard model. The two new ones I showed are literally what they were showing for, oh boy, there was two particles, I can't remember the names of them right. Well, they're the neutrinos. Yeah, they're just the neutrinos. Muon neutrino and electron neutrino. The muon neutrino is the black one, electron neutrino is the white one. Why they won't accept that, I have no clue. So why are these new particles? My particles are the particles they were looking for. They say they could never find them. Well, I found them. The existence of these two particles explains the puzzling properties of the symmetry of the strong nuclear force. And it does. It explains everything. But and then it shows the forces that bind particles into protons and neutrons. Absolutely. And protons and neutrons into nuclei of atoms. That is exactly what I showed. Exactly. And they come down here. Moreover, the same additional particle may be a particle of dark matter, and it is a mysterious substance that accounts for the vast majority of matter in our universe, and it does, because that sucker is heavy and it does not compress. It's just big and solid, case closed. All it is gravity. The white particle can gush down and get bigger and so forth, but it has no impact value whatsoever. Well, I'm going to show you something. Look at it one more time. I've shown it over and over and over. And it absolutely demonstrates what happens with electrons when they leave the dark particles. The electron portion is just a burner. All right, now pay close attention. This is absolutely critical you understand this. That is the particle. Those are photons of light. They call them 2p, two particles, 2h, two holes. They're now calling them tetraquarks, which is they make up all the little elements. Well, yes, there they are. Now, that is when they're glued together. And here's what they look like with their radiance and their different, energetic values. The black has no energetic value whatsoever. It's a complete sucker. It's only exactly the same as it was on both sides. They never change. They're the same size. They're the same density. They're the same weight. They impact. They do not compress. These can glow as they impact oncoming particles. You see this? This is going this way. This is impacting these particles that are in the air, so it's building its charge. Well, the black particle is doing the same thing. It's impacting whatever's there. It doesn't do anything. You couldn't care less about it. This one here is behind it, so it's not doing anything either, but it wouldn't do anything anyway. It just wants to hold on to white ones. This one's diminishing its power because it's behind a black one. Now, what about this? This is what we're looking at when we're actually seeing it. This is the enhancement of the field effects. And Fabien Boulez did the field effects enhancements on a lot of this. And Rod Warren did the actual physical experiments primarily. I did some too, but not like Rod. Rod's the guy. Now, when they came in, I showed you black and white particles. They were attached. They were not. They were glued together, as solid as you can glue anything together. I'm going to tell you right now, they are tight. And there was one here, and then there was another one back to back. That's what caused this effect. When it hit the Venturi, the black one, as I showed you, was a big black ball. Basically, they look virtually exactly like this. This is the black one up here. It never changes, ever, ever, ever. It comes in fast and smashes and just keeps going. This one comes in fast, smashes, and showers because it's a pusher. And it can glow. It can grow like huge. But it can squirt down to nothing, too. And squirt right through that Venturi. And that's all this is. That Venturi is basically this right here. Right? And that particle has to squirt through here. The black ones can't make it. They're too big. They're this big. They come down and they slam all in here, and they can't make it. And what happens as a result is the little ones get pew, 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 and they squirt into these absolutely fabulous fields. Now, what does the end result? What is it? Well, let's take a closer look. All right, if you've been paying attention, it's pretty obvious the muon and the electron neutrino, one of them created the showers, which is the white one, and the black one just stayed exactly like it was. It never impacts. Now, this is exactly what CERN and Fermilab had hoped to achieve and never have been able to. If we can intervene right in here with some kind of a harvest device, like this, right in here, which is called a thin film, transition metal panel. And when those electrons hit it, those transition metals will conduct down through, and through our devices, and then they will come back to join with the white particles. And at that, between the two, you've got a bazillion tons of electrons and power. These are very, very, very energetic particles. Let's look at them in their wide openness, and you can see how energetic they are. It doesn't take a rocket scientist here. Let's just start from the red pulse laser. The particle's way back here. It has a magnetic field that surrounds it. So it's pushing all of these other little tiny particles. And you can see they're little bitty tiny particles. They are electrons. Any electron that gets pushed by electrons coming this way, which is light, will glow. Very simple. Now, I showed you how the Venturi works. It makes a slit so tiny that only the white compressible parts can get through, and the black cannot. So it slams into these and makes these, you see these here? Those are reverse. It should be going this way. That's because there is such a violent concussion and compression and explosion here. And that's literally an atomic explosion. I don't care what anybody says. That is fission. The black has separated from the white. That is fusion. The black has come back to the white. You have them explain to me why that isn't fission and fusion. They can't. It's impossible. I have created, Rod Warren and I basically created and understand nuclear fission and nuclear fusion on a desktop. That's pretty damn impressive to me. And I would never have known this myself. I'm giving credit to Rod. Rod is the guy. If he hadn't been posting these pictures on the internet, nobody would ever know this. And he was only posting them he didn't know what he got. Nobody knew. But I did, because I studied this stuff deep, deep, deep. And when I saw this, I said, whoa. I know exactly what's going on, and still to this very day, not a single physicist will step up and even talk to me about this. I've asked Don Lincoln from Fermilab, will you please take a look at this? You guys are looking for these muons. He said, well, you're not peer-reviewed. We can't look at it. So I don't know. That doesn't really make sense to me. But I'm not in that field. But let's look at these particles. This is so amazing. You can see every single particle there is. See, this is another order of magnitude deeper. You see the black ones? They don't change size. They're just look at them. They're just laying around here. Bang, boom, bada, boom. Well, right here, they can't get through the slit. This is only a single slit. So don't think about this double slit making these interference patterns. The interference patterns are repulsion patterns. This guy here doesn't want to be next to another white guy. He says, get away. And that one says, no, you get away. He says, all right, I tell you what, let's set up a zone right in between us, and when you stay away, I'll stay away. Okay, good deal. And that's how these patterns get set up and these stripes come through. Now, the additional thing is that the light is actually spinning in a circle, and I'll show you that. But this is the separation of the particles, which we absolutely, no question whatsoever, saw they were together. And not only are the red ones like this, the green and the blue too. It's color chromodynamics, they call it now. And they're the same particles, it's just they spin different speeds. Basically, I believe that's the case. And let's take another look. Before we do, don't forget, you're seeing fission. Absolutely zero question. You're seeing fusion. Zero question. To be ignored is not acceptable. When we are in the crisis we're in, and the possibilities that you see sitting right in front of your face, not some pie in the sky nonsense, to not be allowed to have it shown because they refuse to peer review me, and then say, because I'm not peer reviewed, I can't, they won't look. It makes no sense. I told you, the green is exactly identical. This one is caught right in the midst of its flip. You see this is leading forward, it's still leading forward, it's going to jump. Let me show you the red ones. I think maybe I showed you this before, but here they are in a trail. They're coming in from this direction. No real big definition. Then they start to stack up here. Then they get real stacked up and they get real spiky. You see those spikes coming up the top? And then they break off over here and split into their individual components, the black and the white, the muon and the electron neutrino. And the muon neutrino becomes sterile. They're called a sterile neutrino. And so this is, I'm not saying things that they don't see, they just don't understand what they see. That's my opinion, and if I'm wrong, I'd like to be known I'm wrong. I'd like to be corrected. And the only way I can get corrected is to interact. Don't tell me to go read something, because I don't agree with what you're saying. I just wanted you to point out this I believe is the same particle, and you see how the black is on the bottom coming forward and the white is on the bottom coming forward. They flip. They do what they call a muon wobble. Now the red, I don't see it. The green is so much more energetic. Let's take a look at it side by side, the red and the green. All right, this is through the same slit at the same time. Fabi and Brule did these. There was a bunch of people doing these experiments. Nobody did the kind of work that Rod did, and Rod was the first guy to come up with it. And again, I would have never been able to really show my electron flood theory, which is 50 years ago I had it, which is saying that light is nothing more than atomic vapor. And that's all it is. It's atomic particles in a vapor form, positive and negatives. The red came through here not spinning real fast, so this is as far as it went. And it was so weak that it got pushed down. You see, this is the trail. It should have gone and fluff come up this way and this way normally. Well, it's all being pushed down because the green is so powerful. A couple of little tiny reds just got slammed up in here somehow. But these are the green particles. They're the same like ones Rod saw. One of them, you see, all I could say is the green is extremely more violent than the red. And that's why I think we can see the red just in its two separate forms without being blurry splitting. On the green, you see a blur as it changes from upspin to downspin, basically. All right, I'm going to do the best I can to explain this. This was put together by Rod Warren, did all the experiments and took all of the pictures and so forth. And we did it with regular CMOS smartphones with a special app that shows these high energy particles as pixelations. I'm going to leave it at that. If you want to fight about it, fight about it. Go look it up. 2014 physics over in CERN, and at the same time I was going to University of Geneva for particle physics, and they had discovered CMOS could pick up these particles of cosmic radiation. They were using them to detect cosmic radiation. Anyway, it's another story. We can see these. There's no question these are particles that are picked up of light that are visible. Now, this is the light coming at us. Remember I showed you there was a white spritz right here. That's that white spritz. Okay, so we're right over here now. Okay? And it's coming at us, and then right here is where the Higgs show up, right here. So this spot is this spot, and they're coming out at us. And right here is where they slam back into reality, and they bang into other particles, and they start to spin, and then they create these spinning disks. That's this here. These, I don't know how he did it, but I'm telling you, it's fabulous. And these are the spinning particles. The light spins. Did I show you that? Hold on. You see, this shows this light spins in a circle. If you're a machinist, which I was at one time, you will realize that is a drill bit tip. That sucker is spinning through there. It's spinning through this way. And the slit is right here. Tiny, 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 tiny slit. Tiny, tiny, tiny. How many times did I say that? Well, I can say a lot more. It's tiny. What happens? Everything's spinning. It's not just one spin. Here it is right here. Hold on. Just like that. You got a magnetic particle. It's coming through the air. Well, it's coming through the air this way. You see it here? Some go that way. Some go this way. Some go this way. Some go that way. You're going to have all of these little tiny interference patterns. And they call them interference patterns. They're repulsion patterns. This line says, you guys stay that way. You stay that way. And everybody says, yeah, you stay there. I'll stay here. You stay here. I'll stay here. Boop, 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 boop. That's what creates these, what they call interference patterns. That's from a spinning particle. All right, now this is another stunner. Again, the light is coming at us. And what we're seeing right after the green, right after the slit, is the same we see is the complete total whiteness. It's forced the blacks to go away from the white. Now, this is what I found kind of interesting here. I think it's off kilter. In other words, it's not a perfect slit. It's sort of flaring. And it might be offset this way. I don't know. I didn't do these experiments. Rod Warren's the guy to credit for doing this. I did some, but and a lot of people did some. So it wasn't just Rod, but Rod was the one that started it. I want to make sure he gets credit for this because they push people to the side, right and left, and this is not going to happen with Rod. Now, the black particles are separated. They're gone. They're not attached to the white ones over here. So as far as I could tell, they're just bouncing around over here. Look at them. They're everywhere. They're everywhere, everywhere, everywhere. You look in here deep, you're going to see them every single place you can see. There's black particles. Over here, none. We call that nada. Nada one. They're all over here. How did that happen? Does that mean we could just push the black particles out of the way and just harvest only white ones? It appears to me it looks like that here. It looked like it in the red for sure. As it came through, there was a border. But this seems like I could slide them to one side and slide the other ones to the other side. That's what it's looking like to me. There is nothing but concussion here. Energetic reaction. There's no bomb going off over here like this side. And this is exactly what happens in a nuclear blast. This would be the side where all the dark matter smashed. This is the side where all the energy just flowed. You can see it. You got to think about this thing on a much deeper level than people do. Okay, I'm going to play this. It's going to be playing at 25% speed. This is the destruction of a house by an atomic blast. Approximately 1 to 2 miles away it went off. Now, my explanation of an atomic blast is everything is coated with electrons, which is the glowy part. All right, everything is coated with them. They force them all so tightly together that once they set off the bomb, they continue to force them together. Those fields cannot stand that. Everything goes. But what goes first is the white ones. The white ones are the glowers, and they have the energy, but they have no impact value. No impact value at all. They're just burners. And when I show my stuff, hold on, I've been showing it over and over. The part that comes right out of the right here, this is the burner stuff. The black particles are the stuff that comes next. And so in other words, what we're going to see is this house just literally burn up, and then poof, it goes flying. And the black ones are just concussors. They know that they're like bowling balls. So let's watch it go happen. Here, this is apparently boom. Now, they're going to see the house. All right, now watch the house. I just stopped it. They have everything here. They have people, not real people, obviously, but they have all kinds of dummies, and they have food, and they have everything in here. They have telephone lines. They have electricity run. They call it Doomtown. Now, watch. I'm going to let it go again. Now, don't forget, this is a very fast event, but I'm running it at 25%, and we're actually seeing this happen at 25% of the speed, but it's still... Watch, just watch. It just burns. There's nothing broke yet. Not a single thing broke. Watch, it's just burning, just burning, just burning, just burning, just burning. Not a single thing has broken. Why would that happen? Now all of a sudden, watch. Boom. No, I stopped it again. What happened here? No more burning. It stopped burning. Why does it stop burning? Why isn't this burning? Before it just sat there and burned. Now everything's just moving. Well, why is it moving? I say it's moving because the first particles that hit were the white ones, and they hit first, and all they have is a burn value. They have the energy. These babies hit next, the dark particles, and they just are bowling balls, and that's what happened. Now, what happened in the core? The core is still now a big, heavy, dense, dark matter core. And it says, hey, I can't live this life without you guys coming back to me, so get on back. Now watch what happens. It's going that way. Why would it turn around and come back? It would only come back if gravity pulled it back. And gravity is nothing more than magnetism. That's all gravity is. Gravity is magnetism. It pulls in other particles of white particles, and every white particle is normally attached to some kind of a dark particle. So that's what collects the dark particles all in a mass. The only part that's got any mass, really heaviness to it, is the dark matter. The white ones you saw, they didn't burn it. I mean, they burnt everything, but they have no mass. They have a ton of energy. The dark particles have no real energy, they just have a lot of mass. It's like a bowling ball. Like a bowling ball doesn't have a lot of energy until it hits something. But you got to throw it to hit it. If it sits there like that, it's just sitting there. All right, so now what's going to happen? My theory says it's going to start to come back. Boom, out it goes, and now, whoa, wait. Let's go back and see that black particle. And it's all turning around and coming back at us. Now here's another example where just nothing but burning. Boom, there it goes. They don't concentrate on it coming back, but you can see it does come back. Let's see if we can find anything better to demonstrate that. Boom, here it goes that way. Now you'd expect it to just keep coming. But it doesn't. It turns around and goes back the other direction. This is one of those houses. Just very little impact at this point. Almost nothing whatsoever other than extreme energy. Now, here comes the bowling balls. Phew. I think that was a brick house or a solid house. And then they're showing these people. Anyway, it goes out and it comes back. We need to talk about this. And you know, if they're looking for these particles, I think we've shown pretty obvious. There it is. There's the white ones burning. Case is closed for that, the burning. They're fusing into whatever other particles are here. And the reason now watch, see if it'll come back if they give it enough time. Yeah, see here it comes back. All right, this one shows the reversal pretty good. So here comes out the blast, and this is being burned by the white. Now comes the heavy-duty particles. Now watch it all go back. It's going back because these particles left over there is the gravity. That's the dark matter. Nice day at work for our soldiers to see what happens to them, man, when we wash them all down with nuclear particles. If you look deeply into the testing and what they did to peoples all around the world. It wasn't just the army guys. All the indigenous peoples had beautiful lives and everything. Absolutely destroyed them. And it's not just for a week or two. It was for eternity, it appears. A lot of them.